A very warm good morning to my dear students. So today we are going to start that organic chemistry, and that will be in the fast track revision series form. Okay, we will deal with some NCERT part, some CBSE part, along with this the entrance part, that also JEE Mains and advanced and NEET questions will be there. We will solve some questions from that also. So let's quickly start this topic. Haloalkanes and haloarenes. And yes, we know that alkanes, haloalkanes and haloarenes, that means derivative of halogen derivative of alkanes and halogen derivatives of aromatic compound. So let's do something about it. Whatever we will cover in this topic, in this series, what we will cover. First, we will cover the classification, then the nomenclature, nature of CX bond, how it is, methods of preparation, how we will prepare the haloalkanes and haloarenes. Then we will know that like methods of preparation, we will cover the 3 points, that is from alcohol, from hydrocarbon, and from halogen exchange. So basically we will deal all the important point in this. And then we will come for the physical properties. In this physical properties, we will discuss about the melting point, boiling point, solubility. And after that, we will do reactions of haloalkane, which is the major part of this topic. Yes. And reaction of haloarenes. Reaction of haloalkanes will include this nucleophilic substitution reaction, SN1, SN2, elimination, reaction with metal. So these things are very important. We will deal one by one. And reaction of haloarenes, we will discuss about the nucleophilic substitution, elimination reaction, and reaction with metals. Although there is some important part in this, so that I will discuss at that time only. So these are the something we are going to explain. That means optical activity we will do, and all this elimination reaction. This is just a recap. You can say that like thumbnail type. Okay, so let's start with this. The first thing we will do, that types of alkyl halide. What are the types of alkyl halide? If you consider about the placement of halide, that means where the halogen is placed. In this case, this is of germinal size, and germinal, that means at the same carbon 2 halogen will be there. Okay, it is also called gem dihalide. Vicinal, that means if two halogens are at the adjacent carbon, two halogens are at the adjacent carbon, then it is called vicinal. And alpha omega, when it is at the terminal, whatever that is there, that will be on the terminal. It may be 1, it may be 2 in between, infinite it may be. And if the halogen group are at the terminal, then only it will be named as alpha omega. And then on the basis of hybridization, that means when we know that, we very well know this thing, that carbon can show only sp3, sp2 and sp hybridization, isn't it? So on that basis, if we check this sp3x bonded, that means the halogen must be attached with the sp3 hybridization. And in this case, the halogen will be attached with the sp2 hybridized, and in this case, halogen will be attached to the sp hybridization. And if we discuss about this sp3x, it is of like 3 types. One is considered as primary, secondary, tertiary, and the important one is benzylic and allylic. We will do one by one. Similarly, if we talk about this sp2x, it is vinylic and arylic. Sp bonded, that means it is called propergel. So if we have to discuss about it, like what are the sp3x bonded? So let me discuss it very quickly in a short way. See, if the carbon with which the halogen is attached is further attached with only one carbon, that means we are talking about the sp3x bond. So this is X and this is the sp3 hybridized carbon. If this sp3 hybridized carbon is just attached with only one carbon, it will be called primary. And if this sp3 hybridized carbon is attached with 2 different carbon, then it will be called secondary. And while if it is attached with the 3 different carbon, it will be considered as tertiary. Hope it is clear. Next is allylic. That means the sp3 hybridized carbon must be attached with the double bonded, that means sp2 hybridized. This is important, you should know this. If the sp3 hybridized halogen is attached with the sp2 hybridization, got it, is attached with the sp2 hybridized carbon. So this is allylic. This is also called allylic. Ye ring allylic ho gaya. You can see this is sp3 hybridized carbon which is attached with the halogen, and it is further attached with the double bonded. So hope it is clear. Very like 1 or 2 questions can be asked from this allylic, benzylic and all that. So you must know this. This is the basic concept of the organic chemistry, or you can say that the haloalkane. So that should be in your mind properly. Yes. If we talk about this, this is called benzylic. How? When it is benzylic, when the sp3 hybridized carbon with which the halogen is attached is further attached with the benzene ring. Please mind it properly. Okay. If the sp3 hybridized carbon with which the halogen is attached is further attached with the benzene ring or aromatic compound, then it will be called benzylic. Got it? Students must be confused, like they get confused in that if, like, let me show you. If we talk about the sp2 hybridized, like sp2x bond, it will be arylic. That means the benzene, that halogen is attached with this carbon, and this carbon is sp2 hybridized carbon. But we will say in this case, if it is arylic, for the arylic we will say that if the halogen group is directly attached with the benzene ring, then it is called arylic. Students get confused in this arylic and benzylic. See, in the benzylic, the halogen is first attached with the sp3 hybridized carbon, and then it is further attached with the benzene ring. But in arylic, the halogen group is directly attached with the benzene ring. I hope it is clear. Yes. And I hope further you will not be confused in this. So this one is, if the halogen is directly attached with the benzene ring, it will be called arylic. Okay. And the next one is, this is vinylic. Vinylic, that means halogen is attached with the sp2 hybridized carbon, but that shouldn't be the aromatic ring. Got it? If it is only sp2 hybridized ring, not the benzene ring, then it will be called vinylic. But if it is sp2 hybridized carbon is in the benzene ring, then it will be called arylic. Hope it is clear. Yes. Now the next is sp x bonded, but like halogen will be added, hydrogen will be attached to the sp3 hybridized carbon, which will be further attached with the sp. Okay, that is called propergene. So this is halogen that is attached with here, it is sp3 hybridized. Yes, this one is sp3 hybridized carbon, and this for sp3 hybridized carbon is further attached with the sp hybridized carbon. Got it? This carbon is here, whatever the carbon is there, that is sp hybridized. Got it? So if the halogen is attached with the sp3 hybridized halogen is attached with the sp hybridized carbon, then it is called propergene. Okay. Now the next is iso, neo, tert and sec. A big confusion in this, in the sec, neo, sec and iso khas karke, that is the, especially in the iso and sec, students get confused in that. So listen, iso is used for the prefix. I am just going to tell you for, this is iso. When we use it, is used for the prefix. We will think for the prefix. Okay, that means if the prefix is at the second position, if the prefix or the branch, whatever we are talking about, that is at the second position in the main chain, in the ring or in the chain, then it will be called iso. As for example, see, this is the branch over here. Yes, and that is on the second position, so that's why 1 2 we can see. Yes, 2 position, this is 1 2, and at the second position the branch is over there, so that's why it is called isopropyl. In the same case also, you can see 1 2 3 4 carbon is there, but the second position there is a branch, so that's why it is called isobutyl. Similarly, you can see here 1 2 3 4 5, so that's why pentyl, but the branch is at the second position. See, it is for the alkyl group. If it would be here like chlorine, so what you are supposed to say, isopropyl chloride. That means at the iso position, chloride group is attached. But if there is no group as such, there is no like carbon is only there, so we will say simply iso, and then the root word will be there. Whatever the number of carbon, total number of carbon, that will be considered. Got it? Okay. So next is neo. That neo means if the quaternary carbon, see, this is the quaternary carbon, you can see this one is the quaternary carbon, isn't it? If the quaternary carbon is further attached with any group, any other, you can say that the chain, that will be, then it will be called neo. So see, in this quaternary carbon, how many carbon are there? 1 2 3, and this is 4. and here it is 5. So total 5 carbon are there. Sorry, 1 here, 2, 3, 4 and 5. 5 carbon are there, which is, so that's why it is called neopentyl. Pentyl, got it? Similarly, in this case, this is the quaternary carbon, but total number of carbon is here 4 and this is 5 and 6. So that's why it is 1, 2, 4, 5, 6, 7. So that's why it is neoheptyl. Got it? Okay. So now the next is tert. Tert, that means the tertiary carbon. Here it was quaternary carbon. Got it? Here it is tertiary carbon. If the tertiary carbon is attached with the main chain, tertiary carbon is attached with the main chain, then it will be called tert butyl. Got it? Tert. This word will be used, tert, because see, this is the tertiary carbon, and with this tertiary carbon it is attached with the chain. That's why the name is tert. Similarly, you can see this is the tertiary carbon and it is ring attached with the ring. Then it is 5 carbon are there, 1, 2, 3, 4, 5. Yes, so that's why it is called tert pentyl. Now next is if. When it is iso, it is for prefix, and iso sec is when the group, the prefix is attached with the second position, is attached with the main chain with its second position. If the prefix or if the group is attached with the second position, like 1 second, if the group is whatever the branch is there, if the branch is attached with the main chain with its second position, then it is called sec butyl. Got it? That means you can see that this is the main chain, okay, and here it is second position. This is the second position. With this second position, it is attached with the chain. Similarly, you can see in this case, second position it is attached. Got it? So then it is called sec butyl. Suppose that if I am saying this is the ring structure, so what is the name for this? Cyclohexane, isn't it? And if I am adding over here, like I have added 1 and 1 second, it's mistaken over here. Let me draw again. Like if I am drawing like this is 1, 2, and here this is 3 and here 4. Okay, so see, in the branch it is 1, 2, 3, 4. 4 group is there, so butyl will be the branch, isn't it? But this branch is attached with this second position to the main chain. So that's why what we will say? We will say that sec butyl cyclohexane. Got it? Like if I'm drawing like this structure, so this is the chlorine is at the second position. So here what I will say? I will use the word iso. Got it? So we'll say that iso, and how many carbon? 1, 2, 3, 4. So isobutyl chloride. Got it? In this case, it will be called isobutyl chloride, while in the above one case, it will be considered as sec. Okay, this is isobutyl chloride, and in this above case, it is sec. So I hope it is clear the difference between the sec and the iso, isn't it? Okay, so now the next thing, we have to start with the nomenclature, and that is nomenclature. That means obviously we have done in the very detailed way in class 11. So here I will discuss some recapitulation over there, and if still there is any problem on this nomenclature, there is a separate video on the nomenclature. You can watch that and get the things clear. Okay. So nomenclature, that means as we know about selection of main chain and numbering of the hydrocarbon, same rule is here. That means we have to first divide the longest chain if the carbon and hydrogen only there, and if carbon and hydrogen are not there, with the other elements, with the other functional group is there, we have to identify the main chain. Got it? And in this case, the halogen will be acting as a substituent atom. So what is the rule? We have to take care of this. Number of carbon will get the maximum priority, and then maximum number of substituent will get the priority, and then the lowest set of locants will get priority, and last may we will write the in alphabetical order. That priority will be given to the alphabetical order. Got it? So first of all, we will check the number of carbon and then the maximum number of substituents. So here some PYQs which was there in your paper, in CBSE paper board exam. So tell me the name for this compound. This is CS3, CH2, CS3. Bia, what will be the name? Yes, very good. It is simple question. 2-bromobutane. Yes. Now the next question is this. This is little difficult, but if you'll try, it's not that much. See, the main chain you have to decide. This is 1 1 1, or you can say that anyhow you can go. So it will be given you three carbons, isn't it? This is 1 2 and this is 3. Okay, so you can see that this is branch under branch. So this can be 1 dash. Can I say 1 dash? Yes. So this will be 1 dash 1 dash 1 dash trichloro, and then 1 1 1 2 3 3 3, and total how many chlorine it becomes? Now it becomes 3 3 6 and 7 heptachloropropane. Did you get that what I said? 1 dash 1 dash 1 dash trichloro, then bracket close, 1 1 1 2 3 3 3 heptachloropropane. Got it? Or the common name is tris, because it is again the complex form, so that's why we will write the tris. And since all the three are same, so that's why I have used the tris and ek ka nomenclature kar diya. That means trichloromethyl, and total will be, this is 1 chlorine, so chloromethane. Got it? Now this is, and here the functional group, that Br is there and the double bond is there. Which will get the priority? Obviously the double bond will get priority because it is suffix. So what will be the name? This will be 1 2 3 4 4 bromo, 4 methyl and pent 2-ene. Any problem? 4 bromo, 4 methyl, pent 2-ene. Yes. Next question, if you see, this is benzene ring and this is toluene. If we are putting over here like it is toluene, isn't it? And this is chlorobenzene. So what will be the name? First, tell me. Yes, it is. This one is called, this can be called as toluene, isn't it? So you can write for this, you can write toluene, or you can write the 2-methyl benzene. Let's start the counting from anywhere. Obviously you can, if you are starting from here, it will be 1 2 3. 3 group will be methyl group will be at the third position. But if you'll start counting from this, it will be 1 2, isn't it? So which will be get the priority? 1, this is 2, this is 3, and the above one is 4. So we can write 1,4-dichloro 2-methyl benzene, or we can write 1,4-dichloro toluene. Instead of this, we can write toluene. Yes. So a few questions. Write the structure of the following compounds. It is 1-bromo-4-sec-butyl 2-methyl benzene. So how to draw the structure? So first you just draw the root word, the benzene structure, and then put the methyl group at the second position. One position you put the bromo, yes, and second position you put the methyl group. And what next? Fourth position you have to put this 4-sec-butyl. Got it? So here the structure. Let me, this is by mistake. I think it will not be, it's not going, it's by default. Okay. So here this is one position. I have put the bromine over here, and 2 position methyl group. Done with that. Now the 4 position sec-butyl. That means the butyl group must be added, but it should be added with its second position, isn't it? So that's why I have done like this. Clear? So okay, the next structure is 2-bromophenyl butane. So for this, the root word is butane. So what we will do, we will draw the root word first, butane, and then phenyl group and bromine. So I just want to tell you about the phenyl. What is this phenyl? If benzene ring is going to remove its one H to get attached with the main chain, then it is called phenyl. Got it? C6H5 formula is called phenyl. So drawn, since no position is mentioned over here, so one position pair I have used here. Okay, and in this second position is for bromine, so second position bromine. So I just want to tell you, ask whether this structure is correct for this name. Yes, of course the structure is correct for the name, because the question is given like this, so we are bound to draw the structure like this only. Got it? But if the structure is given like this name will not be like ye name nahi hoga. I don't know why it's wrong, like wrong structure is given, and that was asked in your board exam. So you have to be careful about this. This is called the main chain, isn't it? This will be the main chain. That means bromobenzene will be the main chain, and this will be butyl. So what will be the name for this? It will be butyl bromobenzene. Got it? I hope it is clear. Yes. Next structure was this was actually also asked in the paper, wrong, but I have corrected it over here. Okay, and correct things I have written over here. So the question next is 2-methyl propyl chlorobenzene. Okay, so how to draw the structure? This is chlorobenzene. So what we will do, we will draw the chlorobenzene structure first, and on its second position we will add the propyl group, and in propyl ke second position pe we will add the methyl group. Got it? So see, this is the chlorobenzene I have drawn. Okay, in this chlorobenzene, one position, it can't be at one position, isn't it? Kyun? Because this is one. If it is one, so this must be four only. Just don't think of this structure because it was given in the board exam. That's why as it is I have written over here. But let me correct it. This is 4 dash. Yes, 1 2 3 4 4 dash, and here it will be the naming like 1, this will be 1, 2, and this is 3, isn't it? Yes, and this will be 4, this will be 3, this will be 2, and this will be 1, isn't it? Here it is 5th, and this is the 6th carbon. Hope it is clear. Yes, so this will be chlorobenzene. I have written 4 position, and 4 position pe this is a propyl group, propyl for this second position pe methyl. So we will write that 4 2-methyl propyl chlorobenzene. Got it? Okay, so now the next topic about the nature of CX bond. That means halogen and carbon bond. What type of what is the nature for this bond? So let me explain this. Due to the electronegative nature of halogen, CX bond is polar. You know that the polar because of the charge difference, because the electronegativity difference. So since there is the electronegativity difference over there, that's why the bond is polar. Got it? That means it has some dipole moment. If we check the order of the size of the halogen, the iodine size is the biggest one, then the chlorine, and then bromine, and then the fluorine. Fluorine size is the smallest one size. Carbon halogen bond length, if we talk about, obviously this is the carbon, and iodine size is big, bromine size is little. If I will draw the structure like this is carbon, and this one is iodine. Okay, this is carbon, this is bromine. Then this is carbon, this is chlorine, and fluorine, this is the carbon, so this is the fluorine. So tell me whose bond length will be high. It's quite clear. Yes, bond length is the distance between. It's not like that we will measure it through the scale. Got it? It's not like that. It is the distance because it is atom jo hota hai, that is smallest, बहुत छोटा होता है. So we cannot measure it properly with the scale, with the help of a scale. There is something extra microscopic thing through which we measure the things. So here it is the distance between the two nuclei of this two atom is called bond length. So here the bond length will be bigger than this, than this, than this. Got it? Now, bond length of CX bond is inversely proportional to bond enthalpies. We know that bigger the bond, smaller will be the enthalpies because वो आसानी से टूट जाएगा, isn't it? So here the CF bond is the smallest bond. That means it needs more energy to break. Simple सी बात है. You can take the example of a big wood and a small wood. Take like you can say take the stick example. So it will be easy to break the long stick, isn't it? With respect to the smaller stick, so same the things are in. So CX bond is very small. That's why the bond enthalpy is quite high than the CCl, than the CBr, than the CI. Hope it is clear. Next, if we talk about the dipole moment, chlorine dipole moment will be more than the fluorine, than the bromine, than the iodine. You can say there that the fluorine has the smaller size, so it is the more electronegative atom, so its dipole moment should be high. Yes, but if you'll get through this dipole moment, the formula is charge into density. It's not only the charge, or it's not only the electron density. It's a charge into density. Okay, so if we take about this, chlorine has the larger distance than the fluorine, so that's why dipole moment is more in this case. Now you can say that then if it is like this, then the bromine and iodine size is bigger, so here the distance will be more high, isn't it? Higher. But in this case, the charge will be less because bromine is less electronegative, very less electronegative with respect to these two. Iodine also. So that's why this will not cope up. Okay, so in this case, the fluorine and chlorine charge are almost equal, almost same electronegativity, not so like it's not almost. You can say that there is equivalent almost like it will be. So distance will take a part in this, and distance will be the what we say determining factor over here. So that's why the dipole moment is CCl will be higher than CF3, CS3F will be higher than the CS3Br with, and then the I. So this can be the important question. Okay. Now the next thing, methods of preparation. So we are going to prepare the like haloarenes, haloalkanes, and there are the three methods in the starting only I have explained, from the hydrocarbon, from the alcohol, and by the halogen exchange. So in that case, the first is going to be hydrocarbon. So let me explain this. With the hydrocarbon, we can do with the free radical halogenation that we have done in class 11th. Free radical halogenation, that means the cleavage will be what? Homolytic cleavage, and it will generate the free radical. Okay, and this mechanism always occur in presence of H nu and sunlight. This is the important factor you have to keep in your mind when the alkane, this is RH. Okay, when the alkane reacts with halogen in presence of H nu sunlight, it gives RX. If excess of alkyl halide will be there, it will give you the mixture of primary, secondary, tertiary, quaternary. Got it? Like this. Like I mean to say, I made mistake over here. If excess of like chlorine we will use, okay. If excess of chlorine we will use, so we will get the chloromethane, matlab like mono, di, tri, tetra derivative of halogen, halogen derivative. Got it? Like in this case, 1 mole of chlorine is going to react with this. It is going to form CS3Cl, and HCl will come out. Second, this is dichloromethane. Then again, if it goes to react, it will form chloroform and tetrachloromethane at last. And there is the mechanism of this you have done in class 11th, and hope it is clear. Okay, so hydrocarbon on halogenation gives various mono, di, poly haloalkanes product. See, but this is not the authentic way or appropriate way to prepare the halogens. Why? Because it is giving you the mixture of all this halogen. So then there is a need to distillation will be there. Then need to separate them. Got it? So this is the method to prepare the free method to prepare the haloalkanes, but not the appropriate way. Okay. Question is there, a hydrocarbon C5H12 gives only one monochlorination product. Identify the hydrocarbon. So this is a good question. C5H12 gives one monochlorin. That means from wherever you want to you want to replace the hydrogen with the chlorine, it will give you only one product. So what you are supposed to do, first you draw the structure of all the isomers of C5H12 and then think. So if I will draw a structure like this is the N-pentane, okay, normal pentane. So it will give you the three product. Kaise? How can? First, either you add here, chlorine can be added over here, chlorine can be here, and chlorine can be substituted the hydrogen from here also. Yes? So it will give you the three monochloro product. If you will draw this isostructure, it has again the two, like four product it can give. First, why not this and this? If you are using this, again the same product. If you are using this will be the same product, isn't it? So that's why I have used three only. In this case, halogen can be attached over here, either here or from here. Yes, so both will be considered as one. This can also be like halogen can attach over here also, two product. Hydrogen can attach here and here also. So that means it is going to give you four products, but we need only one monochloro derivative. So next structure is neo. If you are drawing the neo, either you attach chlorine from here, chlorine here, or you attach chlorine here or here or here. It is going to give you the same product, only one product. So that's why the neopentane is the structure of C5H12, which will give you monochlorination product when like it is treated with the halogen in presence of sunlight. I hope it is clear. Yes. So this is from the alkene we are going to prepare the haloalkanes. So if the alkene, whatever this is, I have used ethene. You can use propene, butene, any alkene. Okay, when this reacts with chlorine in presence of CCl4, this gives the addition product. Got it? So what will happen? Wherever the double bond is there the chlorine, the halogen group will be attached. Got it? So double bonded where jahan bhi hoga, that is going to remove and that chlorine will be added to there. So it will form the vicinal dihalide. Got it? So in presence of Cl2, CCl4, you have to keep in your mind that it will always give you the addition product and it will result in the vicinal product. Yes, addition product and vicinal product it will form. Okay, विसिनल डाइहैलाइड जिसे हम विक भी कहते हैं. Okay, now this is unsymmetrical alkene. When this unsymmetrical alkene reacts with unsymmetrical reagent, okay, this reagent is unsymmetrical. It's not Cl2, it's HBr, Hi, HCl like this. So as I have explained that if we can use HCl also, HBr also, Hi also, but in this HBr case only, it will be called Markovnikov. Whether and rest all with this HCl and HBr, it will follow the Markovnikov way, like Markovnikov mechanism. Okay. So in this case, if like the bond can be break on both sides, it can go either in this side or it can break on this side also. Yes. So this will give you two rules, that is Markovnikov and anti-Markovnikov rule. Okay, according to Markovnikov rule, it says that halide group will attach to that double bonded carbon atom where hydrogen number is less. Okay, what I said, halide group will attach to that double bonded carbon atom where halogen is less. So halogen is where hydrogen is less. So hydrogen is less over here, so that's why the chlorine is going to attach over here. And according to Markovnikov, this will be the major product. While anti-Markovnikov says that if that halide will attach to that double bonded carbon atom where hydrogen is more, that means it is going to attach to the first carbon. So anti-Markovnikov according, this will be the major product and this will be the minor product. While Markovnikov according, this will be the major product and this will be the minor product. If you want to go for the mechanism we have done already in detail in class 11. So just refer to class 11th, think of read that. Otherwise, in the class 12th board, it won't be asked. That this mechanism won't be asked. Okay, so don't worry about that. See, in anti-Markovnikov, whenever we follow this, it is always occur in presence of peroxide. Okay, in presence of peroxide, and that is the reason that in anti-Markovnikov rule, it follows the free radical mechanism. Okay, ये follow करता है free radical mechanism in anti-Markovnikov, while in the Markovnikov it follows the heterolytic. I don't know why my mouse is not working properly. Okay, free radical mechanism it follows in anti-Markovnikov, and in Markovnikov it follows the what? Heterolytic cleavage. Okay, that means carbocation formation. Heterolytic, that means you can say that the carbocation formation. Okay, so this is the important point you have to keep in your mind, because in the Markovnikov rule, heterolytic cleavage follows, that means carbocation formation takes place. So that's why secondary carbocation is more stable than the primary carbocation, and that's why it gives the 2-chloropropane, like 2-chloro derivative or 2-chloropropane. While in this case, anti-Markovnikov, again, if you just check, this is it follows the free radical mechanism. So in this case, it will give you the primary halide, and that is why how you can go with the mechanism. You can learn this. Okay. Now in this case, suppose that I have given HBr peroxide. If anywhere this hydrohalic acid ke saath peroxide is mentioned, it is quite clear that it is going to follow the anti-Markovnikov rule. That means the negative part will be attached to that double bonded carbon atom where hydrogen is more. Did you get that? I hope it is clear. And one more thing, anti-Markovnikov rule is also known as Karaschmau effect. Yes, this is also known as Kareshmau effect. Kareshmau. Instead of peroxide, it can also be mentioned over benzoyl peroxide. So peroxide in any terms, if it is given with the hydrohalic acid, you have to follow the anti-Markovnikov rule. I hope it is clear. Yes. Chale, next methods of preparation from alcohols. We are going to study with the alcohols, how it is prepared. And these are the very important method. So this is alcohol. If it is reacts with HBr, ZnCl2, it will give you RBr. Even we are not using this. In this case, let me draw all that and then I will explain. Okay. So if in that ROH with that any HI you can say or HBr or HCl you can use and they can form the reaction RBr. But little difference is there here with the HBr and HI, it has some problem. Why? Because let me explain you. Because we cannot this HI and HBr are highly volatile. Okay, so that's why we cannot store them in the in our chemistry lab. So how it will form? Like if we have to prepare the HBr, RBr or HRI, what to do? So for that, basically this reaction is done. For like we add this P plus Br2, that means Na-Br and H2SO4 if we'll add. So what will happen? This will first form HBr over here. Okay, and Na2SO4. So this HBr जो freshly prepared hoga and that is going to react with this ROH to form RBr. Similarly, in this case also we have to use NaI plus H2SO4. So what it will give you? It will give you Hi and that Hi will further react with this ROH to give Ri. Got it? So this is the exact method. This is the appropriate method to prepare the bromoalkane or or iodoalkane. Got it? HBr or Hi we generally don't use. What is the reason? Because I have told you that HBr and Hi are highly volatile. So we cannot store them in the lab. एंड जब हम स्टोर कर ही नहीं सकते तो हाउ वी विल यूज दिस, हम इसको यूज कैसे करेंगे? गॉट इट? सो व्हाट वी विल डू, वी विल मेक इट इन सीटू. इन सीटू का मतलब इन द ट्यूब वी विल मेक इट एंड वी विल यूज एट इमीडिएटली. गॉट इट? समझ में आई बात? Okay, now this is HCl plus ZnCl2. This reagent is called Lucas reagent and this reaction is known as, ये particular जो reaction है, this reaction or this process is known as Group's process. Okay, this process is known as Group's process. So let me mention over here. Group's process. Lucas reagent, one of the famous reagent to identify the primary, secondary and tertiary alcohol. If it would be tertiary alcohol, it will give you the immediate turbidity, that means immediate formation of RCl. Got it? If it is secondary, it would give you the turbidity after 4 to 5 minutes. But if it is primary, it won't give the turbidity at the room temperature. Yes, of course, that will also react, but after heating. Got it? So this is very important. You have to learn for this. HCl plus anhydrous ZnCl2 is called Lucas reagent and this process is called Group's process. So Lucas reagent is used to detect, used to determine, used to separate primary, secondary and tertiary alcohol. Okay, tertiary alcohol will give you the immediate turbidity while the secondary alcohol will give you the turbidity after 4 to 5 minutes and primary alcohol will give you the turbidity after heating. Got it? I hope it is clear. Yes. Now next thing, this conc HI if we are using, then also we can get the Ri. Okay. Now next is SOCl2. If I'm using this thionyl chloride, it will give you RCl SO2 plus HCl. There is a mechanism for that. You can do it, but I don't think so important. And this reaction is Darjan's process. So in the board or the entrance, it never asks the mechanism. If you want to do the mechanism, I will add one more slide for this, and in the PDF you will get it. Okay. Darjan's reaction. This is called Darjan's reaction. Done with that? So now next is PCl5. This alcohol can react with PCl5 as well as with the PCl3. If it reacts with the PCl5, it will give you, in both the case, it will give you alkyl halide. Got it? The only difference is in the side product. If we are using the PCl5, it will give you the POCl3 side product, while if we are using PCl3, it will give you the side product H3PO3. Got it? So in this, the three things important I have explained: the Group's process and the Darjan's process, and how to prepare this IDO. And we cannot directly use HI and HBr like HCl. We cannot use because it is highly volatile. Achha, one more thing. If it is, in this case, I'm using this anhydrous ZnCl2. If it is tertiary, agar ye tertiary hota, so there is no need to use even this ZnCl2. Why? Because tertiary carbocation is so highly stable that to form the tertiary carbocation, it doesn't need any, any catalyst, any electrophile generator की जरूरत नहीं पड़ती, because it is highly stable. It is going to convert into the highly stable carbocation, and that's why it reacts very fastly, even in absence of ZnCl2. Okay. Now this is the method. Like we can use this SO2 will form and H will come over here. If you see the mechanism, this is the structure. Let me show you mechanism over here. This is SO and this is Cl and this is Cl, isn't it? Okay, so here what is this? Lone pair. Clear? And in this case, since the sulfur is, this is the nucleophilic center, isn't it? Because it has lone pair. And in this case, the sulfur will act as the electrophilic center. Why it will? Because it is attached with the electronegative atom. That means the chlorine is stretching its electron on its side. Yes, oxygen is stretching its electron on its side. So sulfur is going to be little deficient कि कब वो chlorine लेके भाग जाएंगे. Yes, isn't it? Electron. So that's why this will act as a electrophilic center. So what will happen? This is going to donate with this. Yes. So if it donates, so the bond will be like it is. Let me draw this. So due to this, because this is nucleophilic center, and here since chlorine is attached with the sulfur, it will work as a electrophilic center. So this lone pair is going to attach with this, and hence it will form a bond like this, isn't it? Now this chlorine will come out as a Cl minus. So since oxygen has lost its one electron, so that's why it will develop the partial positive charge over here, which is highly unstable. We know that. Yes. So anyhow, it will try to complete its it will try to bring its lone pair वापस से. So in this case, what will happen? This H being better leaving group will leave its position, will leave its electron, and will come out to make a bond with this HCl. Got it? So this will form a bond HCl. Let me write over here HCl. Okay. And what will happen? Since it has left its electron, so that's why now the oxygen will have the two lone pair over here. Yes, isn't it? One was already, it was there, and one. Now again, the one still, the electrophilicity of this sulfur is still there because chlorine is attached. So in next case, what will happen? This chlorine will again take its own electron and will take its electron and will come out. So due to which it will have a partial positive charge. So again, the oxygen, since it is having lone pair of electrons, so this lone pair of electron is going to shift on the where this lone pair will be given on this, isn't it? And hence it will form a bond like this. Will be now next product will be like this. Yes, and this is again oxygen will develop the partial positive charge because it has lost its one electron, isn't it? Yes. And this will form double bond over here, and this is S double bond oxygen over here, isn't it? And this is Cl minus. So what will be the next step? Yes. Now what will happen? This bond is going to break and will generate the carbocation, and oxygen ka double lone pair aa jayega. SO2 will come out and it will have the carbocation over here. this will carbocation. So now this carbocation and this Cl will is going to react to form this chloro. I hope it is clear. So this was the mechanism with the Darjan's process, although it will not be asked, but I have explained over here. Above method is not applicable for the preparation of aryl halide because we know that carbon-oxygen bond in phenol has partial double bond character, and since the resonance stabilization, so that's why it will not break easily. Here in that phenol we see there's a double bond over here, double bond and double bond. So this one is the lone pair is involved in the resonance, and that's why this bond is not going to break easily, and hence this reaction won't occur further. Okay, so now this is the mechanism of next HI with the HI I have drawn over here. So see, the question can be asked that this is the equation, and both the product will be asked, like these are the two product it can form, or it can ask in the form of complete the reaction, this dash plus dash. So what equation, what form product will form, you should know the mechanism, then only you can form. So let me show the mechanism. Okay, see, oxygen is having lone pair of electron, two lone pair of electron. We know that electron rich compound. So in this case, Hi will have some partial plus charge. Yes, so due to this, it will attach to this oxygen, rich oxygen. Okay, and hence since oxygen is bonded with one lone pair, so that's why it will have positive charge. So what next? This bond will break on this and it will give you the H2O. Yes, H2O will come out and it will lead to generate the carbocation over here, isn't it? So now the negative charge will attach to this and it will give you the product like this. Clear? So one product is this, product number 1. This is the product number 1. And in another case, suppose that if this structure undergoes resonance, hence the double bond will shift over here, and now the positive charge will be over here, isn't it? So now the carbocation is at this position, I minus will attack on this and it will give you this product. So this is the second product. So there are the two products can be formed, and now you just tell me which one is more stable. Out of that, which one is more stable? This one is more stable. Why? Because yes, it is secondary carbocation. So secondary carbocation will form easily, and here it is primary carbocation. So this is easily and stable hoga, so that's why it will give you the secondary iodine iodine derivative very easily. I hope it is clear. So this is the mechanism. This was the question asked, and in JEE mains also it is asked once. Okay, so next thing, methods of preparation by the halogen exchange, and that will be the last method. Few extra question will be there, for few extra reaction will be there for the preparation of haloalkanes. Okay, so halogen exchange is of two type. The first is Schwarz reaction and the another is Finkelstein reaction. Schwarz reaction 1892, it was given by Schwarz, and it says that the halogen group can be what we say, the chlorine group can be substituted by other halogen group. Okay, like SbF3, SbCl5, Hg2F2, एनी इनऑर्गेनिक सॉल्ट के साथ इसको हम रिप्लेस कर सकते हैं. वी कैन मेक द फ्लोरो कंपाउंड. सो एक्चुअली श्वार्ट्ज रिएक्शन जो होता है दैट इज यूज्ड टू मेक द फ्लोरो कंपाउंड. गॉट इट? To make the fluoro compound. If you want the fluoro compound, that means exchange of chlorine and bromine can be done with the inorganic inorganic solvent like SpF3, AgF, like Hg2F2. So these are the inorganic solvents. So what will happen? Instead of this chlorine, fluorine will be attached. So like this is product. If I'm using 2 chlorine over 2 F, so first in this case one chlorine is substituted by fluorine, and in this case next also if you will use one more, the third one will also be substituted. Okay, Finkelstein reaction, it is used to prepare the iodine. This will be used to prepare iodine. Okay, iodo compound बनाने के लिए we will use this. In this what we will do, this is like Rx plus Ni in presence of acetone and reflux. Reflux means that acetone is first vaporized, okay, and then stored and condensed, and then it is used. Okay, so that is called reflux. So when this NaI in presence of acetone is used, this halogen, which can be chlorine and bromine, which will be substituted by iodine, and this will form NRI. Got it? So this was given by Finkelstein, so that's why it is called Finkelstein reaction. So after that, halogen exchange, few reactions are there which is very important with respect to that JEE Mains and advanced NEET. So this is allylic substitution. Allylic substitution says that when the allylic group, any double bonded compound, if it reacts with this reagent will be here chlorine, we can take any halogen in presence of sunlight. Okay, if we do in general, see, if in this place H nu, in that place of H nu, if I have I have used that CCl4, then it would give what? That addition product, and both the chlorine will be attached to this point, isn't it? But in this case, I'm using H nu. So in the presence of H nu, we know that it will always give you the substitution reaction, isn't it? Let me mention it as a X. It will always give you that substitution product. Okay, so substitution product, for this substitution product, if you'll check, this only the sp3 hybridized carbon is possible for that, isn't it? So what will happen on this, the H will come allylic position, the H will come out as a HX, 1X and 1X will be attached. Clear? So this is the 3 point important point dhyan rakhenge, that is, if any halogen can be used at high temperature or in presence of sunlight. But if we want to use only bromine in this case, like if you are using NBS, N-bromosuccinamide, then only bromine will be attached. Okay, and if I'm using SO2Cl2, then only chlorine will be used. While high temperature or presence of H nu can be used for any halogen, that's why I have written over here X. Yes, it can be used for chlorine, it can be used for bromine, any. But if I'm using NBS, N-bromosuccinamide, it will only give bromo halide, and SO2Cl2, it will give you the chloro. So like this is the example, allylic chlorination. Let's see the mechanism. What will happen? There will be the free radical mechanism. It will generate 2 Cl free radical. Now this one, in this case, this H is going to make a homolytic cleavage will be there, and it will generate the primary free radical over here, isn't it? You can see, and this H free radical, and the Cl free radical will come out as a HCl. So this is going to give you the primary primary. We can say that the free radical. Yes. Now what will happen? Another molecule will break. Chlorine molecules are there. Another molecule will break, and it will give you the free radical over here, and this will also free radical. So this free radical will be there for the next reaction. Further reactions और भी होते रहेंगे इसमें continuously, and one free radical will attach to this to make a compound over here. So in this case, allylic position, agar suppose that if you would have like shifted the bond over here, then also it will give you double bond over here, and this will result like this. You can see here. So in the both case it is same, isn't it? Now in this case, the Cl will come to this point and the same product will be formed. So either you use this, that means you are supposed to say that you are supposed to understand this thing, that if we are using the high temperature or H nu, it will give you allylic substitution only. That means allylic carbon, allylic hydrogen will undergo substitution. Okay. Now this allylic CH bond relatively easy to dissociate. आसानी से हो जाते हैं. Why? Because it is going to give you allylic free radical. Yes, this is allylic free radical, and we know that if the stability, we talk about the stability of the carbocation, that the benzylic carbocation is the most stable because of resonance. Then lesser than that is allylic because of hyperconjugation, and then tertiary mesomeric effect, and then the tertiary due to the hyperconjugation, secondary and primary is the least one. Got it? I have explained you so many times. Now a termination arises from any combination of radical. You can use any combination of radical. आप इससे use कर लो या इससे use कर लो, because there is a homolytic cleavage, so we can use any free radical. Okay, so this was the important point. This 3 point I have explained, that was the important for this allylic substitution. Next, if you see that Hunsdeicher reaction. Hunsdeicher reaction is when the silver salt of fatty acid reacts with bromine in presence of CCl4 reflux. It will give you RBR. This is never asked in your board exam, and this is even not asked in the JEE mains and advance also, but one point of this is asked, and that point is this. We know that the question will be asked, Hunsdeicher Borodine reaction follows which mechanism? First question. So you have to know this. It follows the free radical mechanism. Okay, first thing. And since free radical mechanism follow karta hai, so it is quite clear that the tertiary product will be more stable and tertiary product will be measure, isn't it? So another question can be asked that primary in the Hunsdeicher reaction, RBR, primary, secondary, tertiary, which one will be the major product? And very without any second doubt, without any second thought, you people will pick the tertiary one. And that is the twist in this question. Although it follows the free radical mechanism, but still the primary bromide will be the major product. Got it? Clear hai? So in this product, it is always one carbon less than reactant, एक carbon कम बनेगा. If it is having R plus CO, so this CO is going to be removed. So one less carbon will be formed because of decarboxylation. Smaller the size of alkyl group attached with the carboxylic group, easier will be its decarboxylation and faster will be the reaction. And that is the reason behind this fact, that why the primary bromide is major product. And इसके पीछे मैंने लिख दिया because primary free radical is most reactive, बहुत highly reactive होगा, because tertiary free radical is going to be stable while the primary free radical will be more reactive. So that's why it will react faster and this will give you the major product. And second thing, it will be least hindered, which is following this this law. ये वाला जो rule आपको बताया गया उसके according, क्योंकि ease of decarboxylation will be like quite high over there, faster होगा वहाँ पे. So that is the reason. Let's do the mechanism over here. This is the silver salt of fatty acid. If we check bromine, this will give you Ag, Br and Co. In this is the, let me take this step 1, Br2, what will happen? This is going to, Br1 Br will attach to this and one Ag, Br will come out as here, Ag, Br. In next case, there will the free radical mechanism and this bromine will take its own electron and this oxygen will take own electron to form this. And we know that this one is highly unstable. So what will do? It will, in next case, it will release CO2 to be stable. Yes. Okay. So in next case, it will release the CO2. And this is R free radical. Actually, this R free radical is not going to react with this Br free radical. इस Br free radical से ये react नहीं कर रहा है. अगर इस Br से react करना होता, so the tertiary product would be the major product. Actually क्या होता है? Now this free radical जो form हुआ, this is again going to react with this one, RCOOBr. Acyl group वाले से react कर रहा है. From there, the free radical mechanism will be there again, and this Br free radical will be there free, and that is going to attach. So in this case, this R should be, ये जो R होना चाहिए, that should be less. वो बहुत छोटा होना चाहिए, so that कि ये easily removal हो जाए यहाँ से. Bromine is will be out, and this CO2 will be out. Got it? And that's the reason that primary free radical will be the most reactive, since it is the less hindered. अगर hindrance भी देखें तो less hindrance होगी, so ये easily react कर जाएगा. So that is the Hunsdeicher Borodine reaction. Why we say Hunsdeicher? Because scientist was given, and Borodine because we are using the Br2 over here. So that's why. And the last reaction in the preparation, that is the Borodine-Simonini reaction. If we are using this in this silver salt, if we are using with this bromine, it was giving bromide, isn't it? But in the same way, if we will use iodine, it won't give iodo. Instead of that, it will give you the ester. And that's why it is important. In the Borodine-Simonini, as like him, that Hunsdeicher, bromine, silver salt of fatty acid, and iodine, halogen, we are using CCl4 reflux, we are using the same thing. But instead of giving Ri, it is going to give you ester. And that's why it is important reaction. So you should know this in that MCQ, it can be asked. Modified form is that instead of the CCl4 reflux, we can use that tetraacetate lead also. In presence of HGO, heat karne pe it can give you. So if we are using this like in this way, इसे हम अगर modify कर देते हैं, so how it will be like, this is acid. Okay, that acid reacts with this halogen. In presence of lead, tetraacetate lead and HGO, it will give you the alkyl halide. and this will come as a, like Hg. If I'm using this, HgX2 will come out, and this CO2 will come out, and H2O will come out. Okay, so this one is the Borodine-Simonini reaction, because we want alkyl halide only, we don't want the ester. So इसे क्या कर दिया गया, modify कर दिया गया, and instead of taking silver salt of fatty acid, we will take the fatty acid only. Okay, so that's it for today, and we have done all that preparation. So hope preparation of haloalkanes we have done. Okay, and hope you all got it. So enjoy it, and go through with this video properly, and learn the things which you are supposed to learn. Next class we will do all that properties of that haloalkanes. And okay, so till then, thank you class, enjoy your study.